Well, hi there everyone. We're going to have a look right now at the first half of the 2012 Maths Methods CAS Exam 1. Okay, so here it comes, 2012 Exam 1, and I'm going to go through the questions blow by blow with you. So I encourage you to have a go first and then come back and have a look, and that would be much more productive for you, okay? And then that would be very good thumbs up experience for you. Now the first question, okay, here we go, we're launching off into the first question. It says if y equals open brackets x squared minus 5x to the fourth, we have to find dy dx, okay? Well, okay, let's do that. I'm saying that making u equal to that thing, okay? So therefore y equals u to the fourth. Therefore, if we're saying let u equal x squared minus 5x, therefore du dx would be 2x minus 5, wouldn't it? And therefore y would be u to the fourth, and dy du would be 4u cubed, and therefore by the chain rule, I'm just doing it all nice and simple in the simplest steps possible for you, we would get that by the chain rule, which would get 4u cubed times 2x minus 5. That gets us that expression. Now, that's it, guys. Do not further engage, otherwise you're likely to make an error, and there's no need to anyway. You're just wasting your time. Okay? If students do further engage and get it wrong, they lose the mark, and it's only a 1 mark question, as the circle just indicated. So be sensible. Read how many marks the thing is worth before you even start it. Yeah, don't risk losing your answer mark, okay? And you don't have to use the U notation if you don't want to. That's fine. If you're confident to do it, full-on chain rule without simplifying it, that's fine. Just don't be an algebra hero and just go and launch into it and get it wrong, you know. Be humble enough just to try it in the simplest possible way, which might take a little bit longer if you're a bit stressed. Yeah? That's what I want you to do. Yeah, thumbs up to you. Here comes the second one. This one basically is, we're saying that f of x equals x over sine x. We have to find f dashed of pi over 2. So we've got to take the derivative of it and then sub x as pi on 2. You want to note well that it's worth 2 marks, so you need some working. That's the first thing you always check, how many marks it's worth. I've made u equal to the numerator, v equal to the denominator. Quotient rule required, yeah? Alright, let's do that. Let u equals x, and therefore du dx is 1. We're making v equals sine x, and therefore dv dx equals cos x. Nice and easy. Now, by the quotient rule, we say that df dx equals bottom d top minus top d bottom over bottom squared, or as you see there, v du dx minus u dv dx over v squared. Now we can just sub it in and plug and play. That's what you get, guys. And now we have to sub in x as pi over 2, and don't mess it up, just be careful. It's unfolding before your eyes, and what does that get us, guys? What does that get us? It gets 1. Isn't that great? Aren't they? Haven't they got a sense of humour, old VCAA? So that's what you do, okay? It shouldn't be a problem for you, just be careful and you'll get the mark, okay? Right, what have I said there? You don't need the U and the V notation if you don't want to do that. You can just go straight into the most comfortable way for you to do it, okay? Whatever you're confident doing. Right? Good. Now, the next question. It says we have to find the antiderivative, actually, of 1 over 2x minus 1 all cubed with respect to x. Now, I teach my students to do this using variable substitution, and you don't go wrong. So I'll do that this way on this occasion, all right? Here it comes. It's worth 2 marks, so you've got to show some working. Let u equal 2x minus 1, and therefore du dx equals 2. Okay, and therefore du equals 2 dx. Now let's do our integral now. Hence we have that thing. Okay, because u is 2x minus 1, so it's 1 over that thing cubed. And you'll notice that instead of a dx there, behind the integrand, I've got 2dx, and then I've multiplied by a half in front of the integral sign to compensate for the fact that I just mysteriously invented a 2 in front of the dx. Now, I haven't changed anything. I've just done a bit of skullduggery, because that 2dx, ladies and gentlemen, is du. Okay? Yes, it is. So we get that. Now, look at that. Isn't that marvellous? Because it's just u's behind the integral sign and no problem anymore. It's just a single symbol and everything's going to be good. So now you integrate with respect to u, like that, and then you clean it up a bit. You don't need the c because it's an antiderivative. But if you put the c in, they won't take marks off you, okay? They won't. But not the other way around. If they say the antiderivative and you leave the c out, you're gone. Okay, there's the answer. Okay, I substituted back at the end for what u was, because you obviously can't leave it in terms of u. Alright, good? Happy? Great. Now we'll go for question 3. We're going very well, aren't we? We're going great guns. This one here, we have the rule of a function h is h of x equals 2x cubed plus 1. We have to find the rule for the inverse function. Okay, the inverse function. Now, you notice they said the rule. The rule just means all you need is the formula. You don't need to specify the domain. If you do specify the domain and get it wrong, then you lose marks. So don't go giving them anything more than what they ask for, and you won't go wrong. It's worth 2 marks. Yes, we need some working. You have to watch the setting out with these. It's absolutely amazing what some students set out. It looks like hieroglyphics. It doesn't make any coherent sense at all. So you have to tell the story so that it makes logical sense what you're doing. Yes, the domain not required, as I said, because they just want the rule. Okay. Now you see what I've done there. I've said let y equal 2x cubed plus 1. I don't like the h business because I'm going to swap the variables around in a minute, and it's a bit more awkward if I've got h's there. Y's, but you use that let statement. You use the let y equals 2x cubed plus 1, then the examiner knows what you're doing. Then you say for the inverse, you swap x and y. So x equals 2y cubed plus 1, and then all you've got to do is solve it for y. Okay? Right, now, what we do now is we get y is that thing, and then we go back to the proper notation. The proper notation, the inverse function rule is, that thing. Don't leave it as y, you'll lose your marks. It's like that. Okay, that's enough. You don't need the domain. Yes, don't give the domain unless asked for the inverse function. That's right. If they ask for the inverse function, you've got to give the domain, but if they just ask for the rule, no, you don't. Okay? Yes, I know, Mr. Computer. I told him all that. He just wants to be thorough. So if you specify an incorrect domain, you lose your mark, which is not very nice. Okay? Don't give them anything else other than what they asked for. Number 1 strategy, guys. Before you leave the question, reread it and make sure you've answered what they asked for, because it's easy to get carried away with tunnel vision, thinking, oh yes, I'm doing this, and then you leave the question and you've left something out. So particularly when you're under stress, so don't do that either. You must use the h minus x notation here. You must, okay? Yes, thumbs up. Now this one here is question 4. Question 4, we've got on a given day the number of x of telephone calls that Daniel receives is a random variable with probability distribution given by da-da-da-da, right? We have to find the mean of x. Well, that's a very easy question. It's 2 marks, so you've got to show some work, King. You know that, don't you? 2 marks. That's the first thing you look at, guys. Now, we're going to work it out now. It's just they call it the expected value, or it's just the mean. So you basically multiply each value of x by its probability, which effectively weights its influence. And then you just work that out. This is technology free, but they're not very hard decimals. So we're getting 1.5, aren't we? Yes, excellento. Now, what is the next bit? Just a minute, I'm having a look here. What is the probability that Daniel receives only one telephone call on each of 3 consecutive days? Well, that's all right. What's the probability of him getting one phone call on any day, guys? I think it's, if you look at the table above, it's 0.2, isn't it? So therefore, for 3 successive days, that is on day 1 and day 2 and day 3, hear those ands, that means it's a compound event and you have to multiply the individual probabilities together, and you get, now this bit's a little bit tricky. Some of you people don't know how to multiply decimal numbers together very easily. So that's the answer, and I believe that there was a lot of variations on the theme. Please be careful. Okay, this is how I do those things, is I work out just 2 by 2 by 2, get 8, and then I realise how many places I've got to go over. One place for each of those 0.2s, and I do it that way. Okay, you watch. Okay, then I go jump, 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 and I go 3 spots over. There it is, there's the answer. Okay, or, 0.008, or you can do it this way if you want to, if you don't like the decimal bit. You can just do it like that, 2/10 times 2/10 times 2/10, which will get you 8 over 1,000. Yeah? Good, Mr. Box, thank you. Okay, how are you feeling, all right? Good, yeah, we're feeling great. Now, okay, Daniel, now this one is an absolute disaster. This was a really rotten question, guys, and very, very poorly done. It says here that Daniel receives telephone calls on both Monday and Tuesday. What is the probability that Daniel receives a total of 4 calls over these 2 days? Well, my goodness. Now, look, that looks very, very simple when you first look at it. What you'd be saying, well, okay, so I receive at least 1 call. What does it say? On Monday and Tuesday. So you could do 1 Monday, 3 Tuesday, 2 Tuesday, what am I saying? 4 calls. Yeah, you go 2 Monday, 2 Tuesday, or 3 Monday, 1 Tuesday, couldn't you? And you could just work it out like that with compound events. But however, there's a very, very big grenade booby trap in this thing. That is the information in the first line. Daniel receives telephone calls on Monday and Tuesday. So there is some given information. Yeah, this is it's 3 marks here, so there's obviously more to this than meets the eye. If you just work that out like I just said before with just simple compound events, that doesn't get you 3 marks. It's not enough working. So as I said, we could have had 1 Monday and 3 Tuesday, or 2 Monday and 2 Tuesday, or 3 Monday, 1 Tuesday, but look at that. That is given. This is a conditional probability question. Oh, yes, 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 yes. That's how I felt when I realised that, and I got it wrong myself. Oh, dear, dear, dear. So, because I was just trying to do the exam really quickly, and you know how it's like, so you've got to be watching that. My goodness, VCAA are sneaky, aren't they? So we really want the probability of 1 Monday plus 3 Tuesday, given the above, plus 2 Monday, 2 Tuesday, given the above, oh yes, plus 3 Monday, 1 Tuesday, given the above. Have I got that home yet? Yes. Look, I think the best way to do this before you drive yourself completely into mental meltdown mode is to do a table of events here, and then just restrict the field to the givens only. That's what I would do. Voila! Look at that. Alakazam. So that's just the straight table of compound events. Like, for example, if you had none on Monday and 1 on Tuesday, you'd multiply the respective probabilities for a Monday times a Tuesday, and you'd get that compound event probability, okay? That's what I've done. I've just basically done a little compilation of all the probabilities for the Mondays and Tuesdays multiplied by each other in accordance with whether you're talking about 0, 1, 2 or 3 calls. Do you get that? Now, ladies and gentlemen, we're going to restrict the field. Yes, that is the field available for he receives calls on both Monday and Tuesday. So the zeros for Monday and the zeros for Tuesday are out of action. Now, let's circle the ones that we really want within that cohort, okay? Yeah, we want the ones that I've listed above. That is 1 Monday, 3 Tuesday, 2 Monday, 2 Tuesday, and, what did I say? And 3 Monday, 1 Tuesday, yeah? Now, it's easy as now, because all you want is the probability of those purple circled probabilities divided by the total possible field that there is. So that's what we, and now look, it's over by the shouting now, but by goodness, to try and work that out under exam pressure, well, you know, I think it's a bit nasty, to be honest. Yeah, so we're choosing the 3 circled thingies from the total field. Yes, from those in the red box, yeah? So let's work that out, and we will come up with our answer, and we will be right. Hence, we have the 3 circled probabilities divided by the total field, and if you work them out, it comes to 0.29 over 0.64. Now, don't leave it like that. Just multiply top and bottom by 100, guys, and you get 29 over 64, and Mr. Box, take it away. That's it. Now, that is a 3-mark question. I'm sure you'll agree. Yes, yes, and you're a star for getting that one right. My goodness, you are. Now, question 5, here we go. How are you going? How's your head? Good, good. Now, this one we have to sketch the graph of a function such that its domain is from 0 to 5 inclusive, and what it is, it's an absolute value one, wouldn't you know? So f of x is minus modulus of x minus 3, and then add 2. And you have to label the axis intercepts, of course we'll do that, and the endpoints with their coordinates. Yes, that's good. So look, we're just going to fiddle with that, just crunch away. It's a 3-mark question, so we're going to be careful. Yeah, that's it. That's it. Label the bits that are important. So rough idea. I'm just going to get a rough idea first. Okay, so what I'm saying is, what am I saying? Okay, I'm calling f of x y, just so that I don't be caught up in all the terminology too much. So I'm saying that I've solved that for modulus x minus 3, okay? To make everything, all the orphan terms go over to the left-hand side. And now I can see what I'm doing. So I'm saying that this is dilation, none. Reflection, yes, there is a y reflection, which means it's about the x-axis. Yes, and we've got a translation. Oh yes, we have got 2 of them. It goes up 2, that's in the y direction, and it goes to the right by 3. So that's what we've done. So let's just take stock. We've got the normal modulus x graph. What have we done to it? We've basically flipped it upside down, rotated it, reflected it about the x-axis. We've moved it up 2, and we've moved it over to the right by 3. So I'm getting the picture. Are you? Good. So there's my rough idea. By the way, when you're drawing graphs, please do them in pencil, because if you mess them up, there's no more grid lines to work on, and you end up with a morass, a big mess. So there's my version of what's going on, guys. There it is there, my rough thingo. Now I can translate that onto the big graph. You'll notice that they didn't ask you for the vertex point, but I put it in. So if you do put it in, make sure you get it right. And if you don't put it in, you won't lose marks because they haven't asked for it. Okay? What am I doing now? I'm working out my intercepts, aren't I? Oh, the endpoint. Okay, sorry, the endpoint. When x is 0, y is minus 1. And when x is 5, y is 0. That's the other endpoint. I think I'm ready to go now, don't you? What they say? Label the axis intercepts and endpoints. Yes, goody goody. Both closed dots, of course. You've got to remember to do closed dots, yeah? Here it comes, da-da-da-da. Whoa! Start labelling your points. Yes, yes, yes. And you don't have to do that 3 and 2, by the way, as I just said. But got nice big red knobbly dots on those endpoints so that the examiner can see them. You don't have to do them in red, but you have to make sure they're visible. Right. Check everything. Check-a-rooney. Yes, yes, read the question. Have you done everything right? Because it's worth 3 marks. Yeah, I think we're right. Yeah, intercepts, done them. Yeah, endpoints, done them. Check-a-rooney, good, yes, yes, yes. Coordinates, yes, I've done it all right. I think I'm right now. Thumbs up. Great, let's go. what we're trying to do now is find the coordinates of the image of the point 3 and 2 under a reflection in the x-axis followed by a translation of 5 units in the positive direction of the x-axis. Alright, well that's easy enough, isn't it? How many marks is that worth? 1, alright. Yeah, that's pretty easy. 3 and 2, I draw a little graph to make sure I wasn't getting it wrong, just to, because this is an exam, you're under a bit of stress. So, 1 mark only. Short and sweet, you can say that again, yes. Answer only is important, yes. So, what I'm going to do is I'm going to say, right, 3 and 2, the first thing is a reflection in the x-axis, so it goes, it goes down there, reflects in the x, so the x is the mirror, so it goes to 3 minus 2, and then we're going to translate it 5 units in the positive direction of the x, so it's going to go there, to 8 and minus 2. No problem. There it is. Reread the question. Are we right? Yes, I think we're right. Yep. Yeah, and put a box around it. Please put a box around your answer, because the examiners are complaining about that too, because you get all this stuff everywhere and they don't know where the final answer is. Okay? Yes, nudge, nudge, wink, wink to you too, mister. Now, okay, what do we got to do now? Right, we have to find the coordinates of the image. No, we did that. Excuse me. Find the equation of the image of the graph of f. The equation of the image of the graph of f under a reflection in the x-axis followed by a translation of 5 units in the positive direction of the x-axis. Okay, so we've got to translate the graph, guys. Well, that's no problem, but there is a bit of a kicker in this. There's a kicker in it. They say find the equation of the image. So you better make sure you write an equation. Any kind of an equation, which means there's got to be an equal sign in it. And you better not go calling the image the same thing as the original function either, because that'll be wrong. It's worth 2 marks, so we have to show some working. Now, there's 2 methods that you can use. We can use the transformations key approach, which is the tried and true, but takes a bit longer. Or you can use the shortcut learn technique approach, which is the cookbook, not very much logic behind it kind of approach. I would be using that one because I want to save time. But I'll do both for you. This is a shortcut method, right? Okay, so I've just numbered. I always do that. I number the transformations so that I can show the examiner easily what I'm doing. So I'm going to say let y, do you see that? I'm not going to let it be f of x. I'm just more comfortable. But I have to say that. I have to say let y so that they know what I'm doing, equal that thing. So, okay, so from number 1 transformation, I'm going to replace the y with negative y, because the cookbook tells me to do that. And I get that. Now, the second transformation, I'm going to replace x with x minus 5, because I'm going 5 units over to the right, and that's what I'm going to get. Okay? Now, alright, that's fair enough. Now, we've got to get our terminology right here. Just clean it up a bit first. And there, now I'm ready to go, okay? Now, what I've said there, see what I've just said. If the image is g of x, because I can't say y equals that mod x minus 8 close mod minus 2, because obviously I've let y equal the original function, guys. You have to be careful. Keep your act clean. So I've said if the image is g of x, then g of x equals mod x minus 8 minus 2, and a box goes around it. Now that's perfectly correct. You could have alternatively said minus f of x minus 5 is mod x minus 8 minus 2. That is, in terms of the original f notation, the newly transformed function would be negative f bracket x minus 5. However, I don't like doing that. I'd rather do it this way. So that's just what I'm more comfortable with. But please feel free, but don't mess it up. Now, alright. Yes, don't say f of x here. Oh no, don't do that. Please don't do that, because that's the original function, not the image. I mean, f of x is. Good, good, good. Now we're going to use the key approach. This is the tried and true method. Any point x and y on f of x is transformed as follows, okay? Right. X and Y from transformation 1 becomes X and minus Y, which I've showed you and alluded to up there with that little purple bubble. And the next transformation takes it to X plus 5, 5 units over to the right and minus Y. Here comes another arrow and, yeah, and a blue cloud this time. How very nice. So that's what we're getting, guys. That's the end of the story. So now we use our key technique. We say the transformed X is X plus 5 and the transformed Y is minus Y. Therefore, you make X the subject and you make Y the subject and you plug those into your original equation. Yeah, it becomes that. Now, I've just plugged in X and Y into the original equation, but hang on, I've got to clean it up a bit. Same result, but I've got to make sure I say the image, yeah, okay, make it very clear. The image g of x is, that's the same thing as really what I've done on the left-hand column, is that thing, okay? Don't leave it equal to something which is wrong in terms of the logic of what you've done, so it's coherent and it makes sense. Thank you, Mr. Box. Do you get that? So you've got to watch those things. If they say find the equation, you've got to put an equation which makes sense. Thank you, Mr. Smiley. I think he's been to the dentist, don't you? Right, next one. What do we got next? My goodness, this is fun, isn't it? Question 6. The graphs of y equals cos x and y equals a sin x, where a is a real constant, have a point of intersection at x equals pi on 3. First of all, find the value of a. Well, what's it worth? 2. Yeah, we've got to do some working. Okay, I think this is, what we're saying is cos x equals a sin x. That's what we're saying. That's a tan question in disguise, guys. Oh, I'm a poet and didn't know it. When they intersect, yes, a sin x equals cos x. Therefore, divide both sides by cos x, and what do you get? A tan x equals 1. That's nice and easy. And therefore, tan x equals 1 over a. But now, wait a minute. They're telling us that has a point of intersection at x equals pi on 3. So what's tan of pi on 3 for you and me? Well, the plot thickens. Yes, of course it is. Tan of pi on 3 is root 3. So therefore we must know they're the same thing, and therefore we can solve it for a today. Hooray! A is 1 over root 3. I've got poet's disease again. I'll have to slap myself. Thank you, Mr. Box. That's good. That's just excellent. So we've done that one. We've really cleaned up very well there. Now, what's the next bit saying to us? If x is within the realm of 0 to 2 pi, find the x-coordinate of the other point of intersection of the two graphs. Okay, so x is allowed to go from 0 to 2 pi. I'm flying high. 1 mark, okay? We're just going to make this short and sweet. If tan of x equals root 3, and you know that the general solution of tan is whatever you got plus k pi, where k is an integer, we can just find the next one within that domain. Yeah, we want those quadrants to not to put too much of a carry on over it. So therefore, I would say that if we've got pi on 3 for the first quadrant, we just need to add pi to that, which is what I said in the first place. That gets us 4 pi on 3. Thanks, Mr. Box. Well, that was pretty easy, wasn't it? Nice easy mark for that one. Oh, my goodness, this is very, very exciting. Okay, so let's do question 7. I think, oh yes, thank you, Mr. Smiley. And we're going to go over the page for question 7. Okay, we have to solve the equation 2 of log base e of x plus 2 minus log of x equals log base e of 2x plus 1. Now, with all these ones, I can promise you, you're going to get a negative solution because they're lying in wait for you, because we always know that x has to be more than 0 if you've got x sitting behind a log term, because log can only take a diet of positive x's, okay? So that's the thing to watch for, guys. Righto, 3 marks. So come on, gird your loins, here we go. Into the algebra. Yeah, that's right. That's right. We've got to have only positive x's available here. Right, now this is easy as we're just going to basically use the log laws. So I've simplified the left-hand side, equated it to the right-hand side, and now we can dispense with the logs now. How nifty. Now we've just got to solve it. Come on, we're going to multiply both sides by x. Good, multiply those brackets out and see where we end up. And we get that. Good, good, good. And now we're just going to get everything over the left-hand side now. Okay, multiply through by -1, which is what I always like to do. Now that's easy. Look, I can see the factors sticking out a mile. 4 and 1, aren't they? Of course they are. Now, see, I told you, look, x is -1 or x is 4. Of course, you have to physically reject the -1 and give a reason, otherwise they won't give you those marks. So please do that, yes? Okay? Now, I didn't actually write an explanation there. You must write one. You must say, but x has to be greater than 0. Can you please do that? Yes. Oh, yes, I did. Oh, no, I didn't. Reread the question, test your solution, make sure it's all right. So please specify a reason as to why you're rejecting the x is -1. Yes, I think we're okay. We've done everything, haven't we? Yeah, good, Mr. Box. Thank you, Mr. Box. Great. And what have we got now? Goodness. A random number, x, is normally distributed with a mean of 100 and a standard deviation of 4. Alright, if the probability that x is less than 106 is q, find the probability that x is between 94 and 100 in terms of q. Well, I can immediately see that the probability, what am I trying to say here? If the probability that x is less than 106 is q, then more than 106 is going to be 1 minus q, isn't it? And that's going to be pretty significant. So I'll show you what I mean. Watch this. 2 marks to show some working. Yes, that's right. Working required for a 2-mark question. Now, yeah, I suggest you draw a picture every time with these things. Now, there's a nice little picture. And we've got it all set out there. So we've got 106. Now we're saying that that probability is, that shaded probability is equal to q, right? So therefore, that's what I was just saying. Therefore, the probability that you've got more than 106 is going to be 1 minus q. Okay, now what are they wanting? What are they wanting? They are wanting the probability of the exact, see that, I'll call that thing that thing we've got there labelled 1 minus q, we'll call that the tail, okay? The leading tail or something. Now therefore, what I'm saying is that the probability of getting x between 94 and 100 will be the same as getting between 100 and 106. Do you see that? Yeah, the probability of getting x between 94 and 100, have a look at the diagram, between 94 and 100 is going to be the same as getting between more than 100 and, between 100 and 106, yeah? So, all we've got to do there, we're going to say that's going to be, okay, split the whole thing in half, right down the middle from 100 and just consider each half. So therefore that would be a half minus the 1 minus q on the right hand side, right? Look at the right hand side. Everything above 100 is a half, and then take away the 1 minus q, which is the more than 106 bit, and you get left with the shaded bit from 100 onwards, which is the same probability as the shaded bit from 94 to 100. Does that make sense? Yeah, alright. That's good. Yeah, that bit. Yeah, okay. And just work that out now. Just simplify it a bit and you get q minus a half. Therefore, the probability of the bit we want is also the same as that. Yeah, thanks. Mr. Box. Reread it. Make sure you're right. Mr. Box is coming somewhere. Yes. Yeah, there he is. Yeah, reread it. Make sure you've done it correctly. And everything will be apples. Okay? Great. Now, this next one, we've got a probability density function now. Well, where would life be without one of them, eh? I think we'll, yes, thank you, Mr. Nudge Nudge. We'll do this on the next page, shall we? Okay, so what do we got here? Probability density function f of a random variable x is given by that beast. X plus 1 over 12 between x is 0 and 4 and otherwise 0. Find the value of b such that the probability of x being less than or equal to b is 5/8. Well, that's a pretty straightforward question. It's worth 3 marks though, so you better watch out. Nice, lots of working here, guys. So, let's, I think, yeah, I'm working out when x is 0, the probability density function is a 12th, and when x is 4, the probability density function is 5/12. Well, it's a straight line function. I think I'm just going to draw a graph of it. Draw the graph, and then I can probably just do a geometrical, I think I sniff a trapezium, geometrical area thing. Yeah, there. See what I've got there? Nifty, eh? So now what I've got to do is I've got to find a mythical, well, not mythical, but so far unknown point B such that the area of that thing I've just shaded is equal to 5/8. Alright? Now, look, I'm going to use the area of a trapezium. First of all, we need the right-hand side height of that trapezium. When x is b, you would get f of x equals, according to the formula, b plus 1 over 12, wouldn't you? Yeah? So therefore, the area of the shaded region is the average of the parallel sides, which I'm doing now, times the height, which is b for you and me. And all I've got to do is equate that equal to 5/8 and then solve it for b. Well, it's too easy. Just a little bit of simplification throughout the nation. Yeah, that stuff up on the numerator in the big bracket is b plus 2 over 12, and then we're multiplying that by b over 2 equals 5/8, and then it's a simple matter to solve that for b. Very simple matter. It's yeah, there's a bit of cancelling there. 8 goes into 24 3 times, so that equals 15. So simple quadratic here, simple quadratic, guys, and factorise that. And I think b is ours for the taking. b equals 3 or b equals minus 5. Now you better make sure you explain that why that b is minus 5 has got to be rejected, because b has to be positive, doesn't it? Of course it does, because we're only dealing with x is 0 to 4. Yeah, so you please explain that though, as I haven't, but you please explain that. Say no, but b must be positive. Now we're going to check the answer. When b is 3, f of b would be, yes, I've worked it out a third. I'm going to work out the area now. That's 1/12 plus a third over 2 times 3, and that gets, oh, yes, 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 yes. And do I get 5/8? Yes, I do. Ah, how sweet it is. Okay, so that's good. Okay, it's very good. Very good. And make sure you reread the question. Have you done it right? Yes. Is everything good? Yes, yes. Mr. Box is good. B can only go somewhere between, but not including, 0 and 4, and it's equal to 5/8, and everything is extra good. We've done it. Thanks. Thumbs up. How are you today? He's doing a good job. Okay, where are we up to now? Alright, question 9. There's 10 questions, I think. What's this? We have to say we've got a function such that reals map to reals such that f of x equals x sine x. We have to take the derivative of it. Alright, we can do that. That's a very simple matter. It's worth how many? Only 1. Oh well. Let's just get into it. So I've got 2, I've called x equal to u, sine x equal to v. So, yeah, so du dx equals 1, and v is sine x, so therefore dv dx will be minus cos x. Oh no, it won't be minus because it's just plus cos x. Goodness, I'm going a bit nuts here. So plus cos x, that's right. And therefore f dashed x equals that, product rule, isn't it? Of course it is. So you get that beast, and Mr. Box. Thank you, Mr. Box. Now, what's the next part? We've got to find the antiderivative of x cos x with respect to x. Well, this is an integration by recognition, guys. It's standard, stock standard, classic integration by recognition. You use the result of part A, which is a hence thing, and we do it like this. Yeah, I'm checking over it. Yeah, I did that, Mr. Computer. Thanks for reminding me. Everything's good. Yes. Now, we're doing this now. What's that worth? 3, is it? Oh, strike. Well, we better be careful. Now, we've got y equals x sine x. We know that. We know that dy dx is that thing. So we're going to isolate the x cos x term by itself. And we're going to anti-differentiate both sides with respect to x, not leaving our dx's out, by the way. That's very naughty, and you lose marks, or you can. Yeah, there you go. Alright, you okay? Good. That's all. Now, we've just got to evaluate that right-hand side, and everything's good. That first term on the right-hand side is simply just reduces to 1, dy, or 1 with respect to y, and the second term is just minus sine x with respect to x. Okay? Now, the first term just becomes y, because 1 with respect to y anti-diff gets you y, and we know that y is, what is it? Come on. Yes, it's x sine x, okay, from the original specification of the question. Yeah, so it's x sine x between those terminals, and I've already worked out the cos x1 as well for you. So, come on, Mr. Snail Trail, we're nearly done. We're nearly done, guys. Yes, that's the first term evaluated, and we just got to crunch through it now and make sure we don't mess it up. Alright, a little bit more, and we're there. Yeah, 5 pi over 12 minus 3 pi over 2, I think that's right. Reread it, make sure you've done everything right, and yes, I think so. Mr. Box, thank you, Mr. Box. How sweet it is. Alright, yes, what have I said there? Don't state A and B. No, don't state A and B, because if you get that wrong, then you're wrong, aren't you? So just leave it. They just said in the form, whatever they said it was, A pi plus B, in the form of A pi plus B. So don't tempt fate, guys. Okay, question 10, and what have we got here? Question 10 says, and I quote, okay, we've got a function such that f of x equals e to the minus mx plus 3x, where m is a positive rational number. Find in terms of m the x-coordinate of the stationary point of the graph. Well, that shouldn't be too hard. How many marks is that worth? I think it's worth 2. Yeah, well, we've got to do some working. Alright, come on, we can do this. We're going to find the gradient function. Is that, yes? Alright, and we have to find the x-coordinate in terms of m of the stationary point. Well, that's going to be pretty easy. We set it equal to 0, and we do that, and then we say, therefore, e to the minus mx equals 3 over m. Now, I think we're going to have to do some logging. That's right, some logging. So therefore, take the log of both sides. You get minus mx equals the log, base e of 3 over m. Okay? Now, so therefore, x is going to be, there it is. There's the x-coordinate. Reread it, make sure you've got everything right, guys. Yeah, the x-coordinate of the stationary point, I think we're okay. Thanks, Mr. Box, we've done it. Okay? We've done it. So, that's pretty good. Now, let's see what we've got to do now. State the values of m such that the x-coordinate of this stationary point is a positive number. Ooh, yuck. What? State the values of m such that the x-coordinate of this stationary point is a positive number. So the right-hand side of that boxed expression has to be positive, guys. I think I can smell a graph coming up here. I need a graph to work out where the graph is positive. Yes, thank you, Mr. Wink Wink. It's only worth 1. Gee, that's a bit crazy. I would have thought that'd be worth more. Well, we're saying that x is... Now, do you see what a little rabbit out of a hat I've pulled there? I've made the log term m over 3 so I could have a plus out the front. Alright? plus out the front because that's not as confusing for me anymore. So if I do a graph, yeah, that's right, and m has to be greater than 0. If I do a graph of that, I can see what I'm doing. Right, that's m over 3 I've plotted on the horizontal axis, m over 3. So therefore, if you said log of m over 3 on the vertical axis, you would get log of m over 3 has to be positive. Isn't that what they're saying? Yeah, when m over 3 is greater than 1. Forget about the 1 over m. That doesn't matter. Okay? Because m has to be greater than 0 anyway. Yeah? It does. So therefore, I'm saying if m over 3 is greater than 1, therefore m has to be greater than 3. Reread it. Make sure you got it right. Yeah, I think it's good. Mr. Box, you're a hero. So that's excellent, isn't it? Excellent. Now, what's this last thing? Are they going to hit us with some disastrous thing? Let's see. What have we got here? For a particular value of m, the tangent to the graph of y equals f of x at x is minus 6 passes through the origin. Find this value of m. Tangent to the graph of y equals f of x at x is minus 6 passes through the origin. Find the value of this value of m. It shouldn't be too hard. That's good, Mr. Star. Yeah, we'll go over the page. Yes, I think we need to go over the page. Right, let's go. For a particular value of m, it's worth 3 marks. So obviously they've set up a. They're not going to let us off without a fight. So we'll give them one, won't we? Right. Let's fight. We know that the gradient function is that. Yes, that's the gradient function. So for a particular value of m, a tangent to the graph at x is minus 6. Okay, well we better just plug and play when x is minus 6 and see what we get. Yeah, but we've got to plug in the thing, the minus 6. Oh, good. That's f of x when x is minus 6. Now, what has that got to... That is the gradient of the tangent, right? That's the gradient of the tangent. And, of course, we know that this tangent is passing through the point... What have I written there? F of... f dashed of x. Oh, yeah. Oh, that's what f of x is. Okay, I'm sorry. I'm getting all mucked up. When x is minus 6, f of x is that expression. I'm sorry, it's not the gradient of the tangent at all. It's just the function, okay? Right, now, here's the gradient function, here. So, the tangent line passes through minus 6 and that point, and has a gradient of that thing. Now, that's what we've got to deal with here, okay? We've got the point that it goes through, and we've got the gradient. And we know that it's got to pass through the origin, so there's no c in the mx plus c thing, if you know what I mean. Yeah, okay? So y equals, now what am I saying? Yeah, we're going to plug and play with the values of x and y in there. Here we go. Here we go. Here we go. Oh, look at it. What a disaster. Oh, it's not so bad. Not so bad. Not so bad. So we're saying y equals mx plus c. That's right. We just have to solve it for c. Oh, c is 0. Good. Good. So therefore we can dispense with the c, and we just have to work out the value of m. Yes, okay. Oh, it wasn't so bad after all, was it? Goodness, it looks pretty gurk. Well, the 18s will cancel, and what are we saying? Yes, yes, okay. I get the picture. Oh, what am I... Oh, I see. I just equated coefficients. Look at that. Now, that was nice. A nice little trick, wasn't it? Oh, yes, that's a typical VCAA performance. Nice, complicated-looking question where you've really got to have your head together to sift through it. So that's m is 1/6. Reread everything. I probably messed the explanation of that up a bit, but I think you get the idea, don't you? you've just got to get the equation of the tangent using the gradient function, plug the value of x in, get the x and y coordinates of the function, and then plug that all into a straight line equation, and then use the fact that c is 0 to get your answer for what m must be. Okay? Alright, thanks Mr. Box. I think that's the end. Yeah, that's it. Perfect score. Yes, that's so excellent. So, I hope you enjoyed that. That was a very long presentation. I've been going for 50 minutes, so I need to get out of here and have a cup of tea. So, thank you all for listening, and I hope you had a good time, and I hope it's of some value to you. That's the most important thing of all. Okay, catch you next time. Bye.